afternoon everybody. Today we are going to see the second chapter in 10th mathematics, polynomials. So what is a polynomial? A mathematical expression consisting of variables and coefficients is known as a polynomial. So next, what is the degree of the polynomial? The highest, if let p of x be a polynomial, let p of x is be a polynomial. So the degree of this polynomial, is 2. In other words, the highest power of x in the polynomial p of x is known as the degree of the polynomial. Here the highest power of x is 2. So we say the degree of the polynomial of this equation is 2. Let's have another example. Let p of v be a polynomial, v plus 6. Here the degree of the polynomial is 1, as the highest power of v is 1. What are the types of polynomials? First, we are going to see a linear polynomial. A polynomial with a degree 1 is known as a linear polynomial. Here, v plus 6 is a linear polynomial. The second is quadratic polynomial. A polynomial with a degree 2. Here the polynomial p of x is a quadratic polynomial, as its degree is 2. Cubic polynomial. A polynomial with a degree of 3 is known as a cubic polynomial. P of y cube plus y square plus 6y plus 7 is equal to 0. This is an example of a cubic polynomial. The highest power of y in this polynomial is 3. Biquadratic polynomial. A polynomial with the degree of 4 is known as a biquadratic polynomial. Now let p of x be a polynomial and p of k be any real number. Let us consider p of x is equal to x square minus 3x minus 4, and p of k be any real number. Let k is equal to 2. Let k is equal to 2. Then the value obtained by replacing x by k is called the value of p of x at x is equal to k. Now let's replace x by k, where k is equal to 2. So p of 2 is equal to 2 square minus 3 of 2 minus 4, that is 4 minus 6 minus 4, 4 minus 10, which is equal to minus 6. So this value obtained by replacing x in the polynomial x square minus 3x minus 4 by k is known as the value obtained is known as the value of p of x at x is equal to k. Now let us consider another polynomial. For example, let us consider the same polynomial. Let k is equal to minus 1. Then p of minus 1 is equal to minus 1 the whole square minus 3 of minus 1 minus 4. Then it is equal to 1 plus 3 minus 4. That is 4 minus 4. That is 0. As p of 1 when replaced through x gives us the value of 0, in the quadratic polynomial x squared minus 3x minus 4. So this real number k is equal to minus 1 is known as the 0 of the polynomial. The 0 of the polynomial x squared minus 3x minus 4. If this can only be applied if p of k is equal to 0. Now let's see the geometrical meaning of zeros of the polynomial. Let us take this graph. So representation of a polynomial in a graphical with zeros of the polynomial in a graphical method is known as graphical meaning of zeros of polynomial. So we know that the k, any real number k can be the 0 of the polynomial if p of k is equal to 0. So how do we represent this in a graph? We already know how to represent graphical solutions of a polynomial. So we find the zeros, the points, and then locate them in the graph. Now for this graph, the line intersects the x-axis at 2 points, minus 1 and 4. So we say that for this equation, x square minus 3x minus 4, it has two zeros, minus 1 and minus 4. Or in other words, we can say that now let us look at some other examples. So here in these graphs, the line intersects the x-axis at 2 points, one at A and the other at A dash. So we say that the equation has two zeros, A and A dash. Similarly, in the second graph, the equation, the line intersects the x-axis at 2 points, A dash and A. So the equation has two zeros, A dash and A. Here the line intersects the x-axis at only 1 point, A. So we say that the equation has only one zero, that is A. Similarly, in the next graph also. Now in the case 3 graph, the line does not intersect the x-axis at all. So we say that the equation does not have any zero. Similarly here also, the equation does not has any zeros. Now at this graph, the line intersects the x-axis at 2 points, 3 points, -2, 0 and 2. So the zeros of the equation are -2 and 0 and 2. Now for here, the line intersects the x-axis at only one point, 0, 0. So the zero of the equation is 0. Now for the next one, here the line intersects the x-axis at 2 points, 0, 0 and 1, 0. So we say that for this equation the zeros are 0 and 1. Now let's look at some example sums. Example 1 in our textbook, Ncert book, page number 27. Look at the graphs in figure 2.9 given below. Each of the graphs of y is equal to p of x, where p of x is a polynomial. Find the, for each of the graphs, find the zeros of p of x. So for the first graph, the line intersects the x-axis at only one point. So we say that the equation has only 1, 0. Now for the second graph, the line intersects the x-axis at 2 points. So we say that the equation has 2 zeros. Now for the third graph, it intersects at 3 points. So the equation has 3 zeros. Now for the fourth one, it intersects at only one point, so it has only 1 zero. Similarly for the fifth one, it intersects at only one point, so it has only 1 zero. Sixth one, it intersects at 4 points, so we say that the equation has 4 zeros. Now we are going to see the exercise 2.1 in the Ncert book, page number 28. First question. The graphs of y is equal to p of x are given in figure 2.10 below for some polynomials p of x. Find the number of zeros of p of x in each case. So for the first graph, the line does not intersect the x-axis, so it does not have any zero. The second graph, the line intersects the x-axis at only one point, so it has only 1 zero. In the third graph, the line intersects x-axis at 3 points, so the equation has 3 zeros. For the fourth graph, it intersects the x-axis at 2 points, so it has 2 zeros. For the fifth graph, the line intersects the x-axis at 4 points, so we say that the equation has 4 zeros. At the sixth graph, the line intersects the x-axis at 3 points, so the equation has 3 zeros. If you like this video, please subscribe and share. Thank you.